A pleasant day, Math Wizards. It's been 2 weeks since we had our last lesson in mathematics because of the holiday season. I do hope that everyone is excited to learn new lessons as we continue our journey with radicals. Today, we will be having writing expressions with rational exponents to radicals. So as we go along with the lesson, let us first have these two expressions. So we have the rational exponent form, that is b raised to m over n. So as we have here, this is an expression with a rational exponent. On the other side of the equation, we have the nth root of b raised to m. In this case, these two are equivalent and they are just, this side of the equation is in radical form. Okay, so as what you can see, you can identify those variables that represented in the left side of the equation and the one in the right side, and let us have and identify those variables. Okay, so in the exponential form, we have x as our base, and on the other side, the base becomes the radicand. Okay, so since we have an exponential form, the exponent p over r, in the numerator, it is the power of the exponent, or the power of the expression. It will be located on the radical form. It will be an expression inside the radical sign. So that will be x raised to p. And the denominator is what we call the root or index of the given expression. Now it will be placed here in the radical sign, the small number that rides in the radical sign. So that is above the radical sign. So that is what we call the index or the order of the radical. So this is already our radical form. So now let us apply what we have. Let us apply the concept in writing expressions from exponential to radical form. Okay, so now let's have 7 raised to 2/3. So basically, this is our base, 7 is our base, 2 is the power, and 3 will be our index. So it will now become, this is your radical, 3 will be placed here, 7 raised to 2 will be the number. So if you are required to rewrite it in simplify and evaluate it, you will just have the cube root of 49, or just simply 3 raised to 3 cube root of the cube root of 7 squared, or cube root of 49 will be. Okay, now let's try x y raised to 2/3. So in this case, it is in a parenthesis, therefore xy will be raised, both xy will be raised to 2/3. So again, 2 will be the power of the two variables and 3 will be the index. So it will now become the cube root of xy squared, x squared, y squared. So the answer now will be the cube root of x squared, y squared. So continuing our example, we have 8x raised to 2/5. In this case, 8 is not raised to 2/5. So therefore, you will just have 8 outside the radical, and 5 will be the index. So you will just place 5 in the radical sign, and you will have x raised to 2 as the radical. Okay, so it's what you can see here. If it is enclosed in the parentheses, like on the second example, x and y is both raised to 2/3. But in this case, x is the only one that was raised to 2/5. Therefore, 8 will be a coefficient of the radical. So we will now have 8 fifth root of x squared. Okay, so let's move on and have another one. So let's have negative x raised to 2/3. Since it is not enclosed in a parenthesis, therefore the negative sign will be included inside the radical. So that will be cube root of, this will be the index and this will be the power, negative x squared. On the other hand, if it is not, the negative sign is outside the parentheses, so this will be negative of the cube root of x squared. Again, this will be placed inside the radical kasama ng x, and 3 will be the index placed in the small portion of the radical side. Okay, continuing our example, we have now x raised to negative 2/3. So you will just write it as since you needed to write it in a positive, you need to rewrite negative exponent in positive, so that will be 1 over x raised to 2/3, and you will just have 1 over the cube root of x squared. So that will be our final answer. The same as what we have in the previous example, this will be counted as one expression. So you will be having the cube root of a squared plus b cubed raised to 2. Okay, so you cannot distribute 2 in the two terms because it is already counted as one term because of the operation plus in between the two variables. So the answer will now be the cube root of a squared plus b cubed raised to 2. Okay, so how about if we are to convert the given radicals into expressions with rational exponents? So now we will just have, let us just identify, since there is no exponent for b, there is no power, it means there is 1 that is an exponent of b. So writing it, we will be having b raised to 1 over, since our index is 3, so 1 over 3 will be the exponent. So the cube root of b in expressions with rational exponents will be b raised to 1/3. On the other hand, if we have the cube root of b squared, again, b will be the numerator of the fraction and over 3. So the answer now will be b raised to 2/3. Now, on the next item, we have the fourth root of 2x. So since it is a fourth root of 2x, you will just have the quantity 2x raised to 1/4. So since there is no exponent present in 2 and 1, it means there is a power which is equal to 1. So that will be 1 over 4. So now the expression will be the quantity 2x raised to 1/4. Let us have another one. So 2 here was not raised to any of the number. So you will just have 2 y raised to 4 will be the numerator, and 3 as the index will be the denominator of the exponent. So that will be 2y raised to 4/3. Next, you have the cube root of negative b squared. So again, you will be having negative b raised to 2 over 3 will be our answer, or that is simply negative b raised to 2/3. So in this case, you have negative outside, so you will just have negative of b raised to 2/3. I hope that you have learned something about our lesson for today. See you again on our next video lessons. Like, share, and comment your suggestions on the comment box below, and don't forget to subscribe. To get notified with our latest videos, just click the notification bell.